Picture this. Every single beam of light reaching us right now is actually a tiny particle of energy, a photon, that has journeyed through space for millions of years. These ancient travelers have crossed vast cosmic distances to tell us their stories. But have you ever wondered what happens when light meets a star? How do these photons transform into the energy that powers our entire universe? Today, we're embarking on an extraordinary journey to explore the mesmerizing dance between light and stars. This relationship is not just beautiful, it's essential to everything we know and everything we are. From the warmth you feel on your skin on a sunny day to the twinkling stars that guide sailors across the oceans at night, it all comes down to this incredible interaction. In this video, we'll unveil the secrets of how light, in its quantized form, is absorbed and emitted by atoms within stars. We'll discover how this process enables remarkable phenomena like nuclear fusion and energy production that keeps our cosmos running like a perfectly tuned cosmic engine. Imagine each star as a celestial lighthouse, not just guiding our way through space, but actually manufacturing the building blocks of life itself. Before we dive deep into this fascinating cosmic ballet, a quick reminder to brighten our universal community. Hit that like button and subscribe to Exploring the Universe to ensure you never miss any content about the wondrous world of astronomy. Together, we'll uncover the mysteries that make our universe tick, one photon at a time. Isn't it amazing to think that the light we're seeing from some stars began its journey when our ancient ancestors were just beginning to look up at the night sky and wonder about their place in the cosmos? Some of these light particles set off on their journey when the Egyptian pyramids were yet to be built, and they're only reaching our eyes now. That's the kind of cosmic perspective we'll be exploring today as we unravel the quantum nature of light and its crucial role in stellar processes. Let's dive into one of the most fascinating revelations in the history of physics, the quantization of light. For centuries, scientists believed light flowed like a continuous wave, much like ripples on a pond. But the truth turned out to be far more intriguing. Imagine breaking a chocolate bar into smaller and smaller pieces. You'd eventually reach a point where you couldn't break it any further. You'd have one single piece of chocolate. Light works in a surprisingly similar way. It comes in tiny, indivisible packets of energy called photons. These photons are the smallest possible units of light, nature's fundamental building blocks of brightness. This revolutionary idea emerged from the brilliant minds of two scientific giants. In the year 1900, Max Planck discovered that energy isn't continuous but comes in discrete packages, which he called quanta. 5 years later, Albert Einstein built upon this groundbreaking work, explaining how light itself behaves as both a wave and a particle, these particles being what we now call photons. Einstein's insight was so radical that even Planck, the father of quantum theory, found it difficult to accept at first. Here's something that will blow your mind. A single photon of visible light carries just 2.5 electron volts of energy, an amount so tiny it's almost impossible to imagine. But don't let that small number fool you. Our sun, just an average star in the cosmic scheme of things, pumps out billions upon billions of these photons every single second. It's like having an astronomical machine gun firing countless particles of light into space. The discovery of light's quantum nature changed everything we thought we knew about the universe. It helped us understand how stars shine, how plants convert sunlight into energy, and even led to the development of modern technologies like solar panels and laser beams. Without this understanding, we wouldn't have many of the devices we use every day, from the LED screens on our phones to the scanners at grocery stores. But the quantization of light isn't just about physics. It's a reminder of how the universe can surprise us with its elegant simplicity. Even something as fundamental as light has its basic building blocks, its own atomic structure, teaching us that sometimes the most basic things in nature can be the most fascinating. Now, let's explore something truly magical, The dance between light and atoms. Imagine atoms as tiny solar systems with electrons orbiting around a nucleus, much like planets around a star. But unlike our solar system, electrons can only exist in specific energy levels. Think of them as cosmic stepping stones, where electrons can jump from one level to another, but never land in between. When a photon of light encounters an atom, something remarkable happens. If the photon carries exactly the right amount of energy, an electron can absorb it and leap to a higher energy level, like a cosmic acrobat jumping to a higher platform. But electrons are restless performers. They don't stay in these excited states for long. When they jump back down to their original level, they release that absorbed energy in the form of a new photon of light. This cosmic light show becomes even more fascinating when we look at stars. The color of every star tells us a story about the energy of the photons it's emitting. The hottest stars, burning at temperatures we can barely imagine, appear blue or blue-white because they're emitting high-energy photons. Cooler stars, though still incredibly hot by earthly standards, appear red because they're emitting lower-energy photons. Think about our own sun, which appears yellow to our eyes. Its color comes from the specific energy levels of the atoms in its outer layers, primarily hydrogen and helium, dancing with photons created in its blazing core. But the sun isn't alone in this cosmic color palette. Betelgeuse, the famous red supergiant in the constellation of Orion, glows with a distinctive reddish hue, while Rigel, in the same constellation, dazzles with a brilliant blue-white light. Here's a mind-bending thought. Every color you see in the night sky is a direct result of this quantum dance between atoms and photons. The light from these distant suns has traveled across the vast cosmic ocean, carrying information about the atomic processes happening in their stellar atmospheres. Speaking of stellar colors, I'm curious to know which one captivates you the most. Is it the fierce blue of young, massive stars, the familiar yellow of stars like our sun, or perhaps the deep red of aging giants? Share your favorite stellar color in the comments below and tell us why it fascinates you. There's something deeply personal about our connection to these cosmic lighthouses, and I'd love to hear what draws your eye to particular stars in the night sky. Remember, when you look up at the stars tonight, you're witnessing this quantum dance in action, a performance that's been running since the dawn of time, lighting up our universe with a spectacular array of colors. Have you ever wondered how stars are born? The story of stellar birth is one of the most captivating tales in our cosmic theater, and it begins in the most unlikely places. Vast, cold clouds of gas and dust floating in space. These stellar nurseries, called nebulae, might look peaceful from a distance, but they're actually dynamic regions where gravity plays the role of a cosmic midwife. Picture a massive cloud, hundreds of light years across, containing enough material to make thousands of stars like our sun. Within these clouds, something remarkable begins to happen. Gravity starts pulling the gas and dust particles together, much like how a snowball grows as it rolls down a hill. As more material gathers, the cloud begins to collapse under its own weight. This process might be triggered by various cosmic events, perhaps the shock wave from a nearby supernova explosion, or the gravitational influence of passing stars. As the cloud continues to collapse, something magical occurs. The material at the center begins to heat up, much like how your hands warm up when you rub them together. This is where light and radiation begin to play their crucial roles. The increasing pressure and temperature at the core start generating radiation, pushing outward against the falling material. It's like a cosmic tug-of-war between gravity pulling inward and radiation pushing outward. The temperature keeps rising, from a few degrees above absolute zero to hundreds, then thousands, and eventually millions of degrees. When the core temperature reaches about 15 million degrees, something extraordinary happens. Nuclear fusion begins. This is the moment a star is truly born, when it starts generating its own energy by fusing hydrogen into helium. As Carl Sagan, one of the most inspiring astronomers of the 20th century, beautifully put it, "The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff." This profound observation reminds us that stars are not just distant points of light. They are the cosmic factories that create the building blocks of life itself. Here's something fascinating. The process I just described isn't just ancient history. It's happening right now. In the Orion Nebula, visible to the naked eye on a clear night, new stars are being born as we speak. Some of these stellar infants are just a few 100,000 years old, mere babies in cosmic terms. Think about this. Every time you look at a newborn star, you're watching a process that will eventually seed the cosmos with the elements necessary for life. These stellar nurseries are literally the factories where the universe creates the materials that might one day become part of new planets, new life forms, and maybe even new civilizations. The birth of a star is more than just a scientific process. It's the beginning of a cosmic legacy that could last billions of years. Each star is a beacon of possibility, a nuclear furnace that will forge new elements and perhaps nurture worlds we can only imagine. And speaking of imagination, I'd love to hear from you. If you could witness the birth of a star up close, what do you think would be the most amazing part to see? The initial collapse of the nebula, the moment when nuclear fusion begins, or perhaps the first light breaking through the surrounding gas and dust? Share your thoughts in the comments below. Let's talk about the most powerful energy source in the universe, nuclear fusion. Inside every star, an incredible process is taking place that would make our most advanced power plants look like child's play. It's a cosmic dance of atoms that powers everything we see in the night sky. At the heart of every star, including our sun, temperatures reach a staggering 15 million degrees. That's so hot that atoms can't even stay together. They're stripped down to their basic components. Under these extreme conditions, something remarkable happens. Hydrogen atoms, the simplest elements in the universe, begin to fuse together to form helium. Imagine 4 hydrogen atoms, each like a tiny building block of the universe. When they slam together under the immense pressure and temperature at a star's core, they merge to create a single helium atom. But here's the fascinating part. The helium atom weighs slightly less than the 4 hydrogen atoms that created it. What happens to that missing mass? It gets converted into pure energy, following Einstein's famous equation E equals mc squared. The amount of energy released in this process is mind-boggling. Our sun, which is just an average-sized star, converts 600 million tons of hydrogen into helium every single second. That's equivalent to the weight of all the buildings in New York City, transformed into pure energy every second of every day. And it's been doing this for over 4.5 billion years. But the story doesn't end there. The energy created in the core needs to reach the star's surface, and this is where photons come into play. These particles of light begin an epic journey that could be compared to the world's longest maze. The energy released by fusion creates photons that bounce around inside the star like pinballs in an arcade machine. What starts as high-energy gamma rays gets absorbed and re-emitted countless times, gradually losing energy until it becomes the visible light we see. Here's something that will blow your mind. A photon created in the sun's core takes anywhere from 50,000 to 170,000 years to reach the surface. But once it breaks free, it takes just 8 minutes to reach Earth. That means the sunlight warming your skin right now started its journey when humans were still in the Stone Age. This process of nuclear fusion isn't just about keeping stars bright, it's the source of everything we are. The iron in your blood, The calcium in your bones, the gold in your jewelry, all these elements were cooked up in the hearts of stars through fusion reactions. We are, quite literally, walking collections of star-forged elements. And here's a thought that keeps astronomers up at night. We still haven't managed to replicate this process efficiently on Earth. Scientists worldwide are working on fusion reactors that could potentially provide unlimited clean energy. But stars make it look easy. They're like cosmic power plants that have been running perfectly for billions of years. If you're as amazed by this cosmic alchemy as I am, hit that like button and share your thoughts in the comments below. What aspect of stellar life do you find most impressive? Is it the sheer amount of energy they produce, the fact that they forge the elements of life, or perhaps their incredible longevity? Don't forget to subscribe to Exploring the Universe for more fascinating content about our cosmic neighborhood. Remember, every time you look up at the stars, you're witnessing these nuclear furnaces in action, each one transforming matter into energy through the miracle of fusion. They're not just lights in the sky, they're the engines that power our entire universe. Have you ever noticed how both plants and stars seem to glow with their own special kind of light? While this might seem like a strange comparison at first, these two cosmic dancers share some fascinating similarities in how they process and produce energy. Let's explore what I like to call stellar photosynthesis. Well, just as plants on Earth take sunlight, water, and carbon dioxide to create energy and oxygen, stars have their own remarkable way of transforming basic ingredients into the energy that powers our universe. Think of hydrogen as the star's version of water and carbon dioxide. It's their basic fuel, their cosmic food source. Plants use chlorophyll to capture sunlight and start their energy-producing process. Stars, on the other hand, use their immense gravitational pull to compress hydrogen atoms until they're hot enough to fuse together. It's like having a cosmic pressure cooker that's been turned up to 15 million degrees. Here's where things get really interesting. While plants release oxygen as a byproduct of their energy production, stars create helium and gradually cook up heavier elements. Both processes are absolutely essential for life as we know it. Without plants, we wouldn't have oxygen to breathe. Without stars, we wouldn't have the elements needed to form planets, or even our own bodies. Think about this. The light from our sun that plants use for photosynthesis was actually created through the stellar version of this process. It's a beautiful cosmic cycle. Stars create light through their fusion process. Plants capture this light to create energy and oxygen, and we humans benefit from both. It's like the universe created its own perfect energy recycling system. Let me share something mind-bending with you. The energy locked inside a single leaf through photosynthesis might seem tiny compared to a star, but the basic principle of converting one form of energy into another is remarkably similar. Both processes follow Einstein's famous principle that matter and energy are two sides of the same coin. And here's a fascinating historical connection. When scientists first began understanding photosynthesis in the 18th century, they couldn't have imagined that stars underwent a similar process of energy transformation. It wasn't until the 20th century that we began to understand stellar fusion, and the parallels between these two processes started to emerge. Just as a forest of trees works together to create a sustainable ecosystem, the stars in our galaxy form a vast network of energy producers, each one contributing to the cosmic web of light and energy that makes life possible. They're like cosmic power plants, but instead of burning fossil fuels, they're fusing hydrogen into helium and creating all the elements we need for life in the process. Here's something to ponder. If stars were like plants in a cosmic garden, what would you consider their food? Is it the hydrogen they consume, the gravitational energy they harness, or perhaps something else entirely? Share your thoughts in the comments below. I'd love to hear your creative ideas about this cosmic comparison. And while we're making these fascinating connections between the small and the large, between the terrestrial and the celestial, remember that you're part of this grand cosmic cycle too. The oxygen you're breathing right now was created by plants using light from our sun, which itself was created through stellar fusion billions of years ago. The next time you see a plant soaking up sunlight or gaze up at the stars twinkling in the night sky, remember that you're witnessing two sides of the same cosmic story, the story of how our universe transforms and circulates energy in an endless dance of creation and renewal. What other similarities can you think of between plants and stars? Are there other cosmic processes that remind you of things we see here on Earth? Share your insights in the comments section below. And if you're enjoying these cosmic connections, don't forget to like this video and subscribe to Exploring the Universe for more fascinating journeys through the cosmos. Every star tells a story, and like all great stories, it has a beginning, middle, and an end. Today, we're going to explore one of the most fascinating aspects of stellar existence, the life cycle of stars. Just as we measure our lives in years, stars measure theirs in millions or billions of years, and their fate is written in the amount of hydrogen they're born with. Think of hydrogen as a star's cosmic fuel tank. The more hydrogen a star has when it's born, the longer it can potentially live. Our sun, for instance, started with enough hydrogen to shine for about 10 billion years. We're currently about halfway through that journey, which means our star still has about 5 billion years of life left in it. Talk about long-term planning. But here's where things get really interesting. The mass of a star at birth determines not just how long it will live, but also how it will die. It's like a cosmic version of destiny written in the stars, quite literally. Massive stars, those with more than 8 times the mass of our sun, live fast and die young, burning through their hydrogen fuel in just a few million years. Meanwhile, smaller stars like the red dwarfs sip their hydrogen so slowly they could potentially shine for trillions of years. As Stephen Hawking once eloquently put it, the stars are like burning logs in a fire. When they have exhausted their fuel, they die out. Their birth and death are part of a cycle of stellar evolution which creates and distributes the chemical elements necessary for life itself. This profound observation reminds us that even in death, stars contribute to the cosmic story. When a star begins to run out of hydrogen in its core, it enters what astronomers call its red giant phase. Imagine a star swelling up to hundreds of times its original size, like a cosmic balloon. Our sun will eventually grow so large it might swallow Mercury and Venus. But this expansion is really a star's last hurrah, its grand finale before the curtain falls. What happens next depends entirely on the star's mass. Smaller stars, like our sun, will eventually shed their outer layers in a beautiful display called a planetary nebula, leaving behind a dense, hot core called a white dwarf. These stellar remnants, about the size of Earth but weighing as much as the sun, will slowly cool over billions of years until they become black dwarfs, the cold, dark embers of once bright stars. But for massive stars, the end is far more dramatic. When they exhaust their fuel, they don't go quietly into the night. They explode in spectacular supernovae, briefly outshining entire galaxies. These cosmic explosions are so powerful, they forge elements heavier than iron, including gold and platinum, scattering them across space. In their death throes, these stars seed the universe with the building blocks for future worlds. The most massive stars leave behind either neutron stars, objects so dense that a teaspoonful would weigh billions of tons, or the most mysterious objects in the universe, black holes. These cosmic heavyweights are so massive that nothing, not even light, can escape their gravitational pull once it passes their event horizon. Here's a mind-bending thought. The iron in your blood was likely forged in the heart of a massive star that exploded billions of years ago. Every time you look in a mirror, you're seeing atoms that were once part of a star's death throes. We are, in the most literal sense, made of stardust. The life and death of stars remind us of an important cosmic truth. Nothing in the universe is truly permanent, but everything is connected. The elements created in dying stars become part of new stars, new planets, and eventually, new life. It's a cosmic cycle of renewal that has been ongoing for billions of years. As we wrap up this stellar life story, I'm curious to hear your thoughts. Which stage of a star's life do you find most fascinating? The long, steady burning of hydrogen, the dramatic red giant phase, or perhaps the spectacular end in a supernova? Now, let me share some absolutely mind-blowing facts about our cosmic neighborhood that will change the way you look at the night sky forever. Picture this. When you gaze up at the stars tonight, you're actually looking back in time. The light from many of the stars we can see started its journey towards Earth before the Great Pyramids of Egypt were even built. Take Deneb, one of the brightest stars we can see. Its light has been traveling through space for over 2,000 years. When that light first left Deneb, the Roman Empire was still in its early days. Some of the photons reaching your eyes tonight began their cosmic journey when our ancestors were just beginning to develop written language. Speaking of cosmic journeys, let me tell you about one of the most exciting recent discoveries in astronomy. We've long wondered where elements like gold and platinum come from. Well, it turns out that when supermassive stars explode, they create something called a kilonova. An explosion so powerful, it literally forges these precious elements in its cosmic furnace. Think about that for a moment. The gold ring on your finger or the platinum in your jewelry was quite literally cooked up in one of the most violent explosions in the universe. Every piece of gold on Earth is made of star stuff. But here's a connection that might surprise you even more. Nearly all the energy we use in our daily lives can be traced back to the nuclear fusion happening in our sun. The gasoline that powers your car, it comes from fossil fuels, which are really just ancient plants that stored the sun's energy millions of years ago. The wind that turns turbines, it's created by temperature differences in our atmosphere, heated by the sun. Even the food you eat exists because plants capture energy from our nearest star through photosynthesis. Here's something fascinating to consider. When you use your smartphone, you're actually using stored sunlight. The electricity might come from solar panels, which directly capture the sun's energy, or from plants that died millions of years ago and became fossil fuels. Either way, it all leads back to our sun's nuclear fusion reactor, 93 million miles away. And speaking of our sun, here's a thought that always amazes me. Every second, it converts 600 million tons of hydrogen into helium through nuclear fusion. That's more mass than all the steel in every building on Earth, converted into pure energy every single second. And it's been doing this for over 4.5 billion years. These connections between the cosmic and the everyday remind us that we're not just observers of the universe. We're an intimate part of it. The energy that powers our world, the elements that make up our bodies, and even the light that lets us see it all comes from the stars above us. Next time you look up at the night sky, remember that you're not just seeing points of light. You're witnessing ancient photons completing their long journey through space, watching elements being forged in stellar explosions, and observing the very process that powers our entire planet. The universe isn't just out there in space, it's right here, in everything we touch and everything we are. What do you find most surprising about these cosmic connections? Is it the ancient light still reaching us from distant stars, the stellar origins of precious metals, or perhaps the sun's influence on our daily energy use? Share your thoughts in the comments below. I'd love to hear what amazes you most about our connection to the cosmos. And now, we've arrived at the most profound revelation of our cosmic journey today, one that will forever change how you see yourself and your place in the universe. Take a deep breath and consider this extraordinary truth. Every single atom in your body, except for hydrogen, was forged in the heart of a dying star. Let that sink in for a moment. The calcium in your bones, the iron in your blood, the carbon that forms the basis of your DNA. All of these elements were created in stellar furnaces billions of years ago. Stars that lived and died long before our solar system even existed crafted these elements through nuclear fusion and scattered them across space in their final, magnificent explosions. When you look in a mirror, you're quite literally seeing stardust that has taken human form. Your eyes, processing the light from distant stars, are made from elements that other stars created. It's a beautiful cosmic cycle. We are made of stars, and we study the stars to understand ourselves. The quantization of light isn't just another scientific concept to memorize. It's the key that unlocks our understanding of this profound connection. Every photon that strikes your retina, every quantum of light that helps a plant grow, every particle of stellar energy that warms our planet, they're all part of an intricate cosmic dance that has been ongoing for billions of years. Next time someone asks you what you're made of, you can tell them the truth. You're made of star stuff. You are a child of the cosmos, carrying within you the legacy of countless stars that lived, died, and scattered their elements across the galaxy. In the most literal sense, the universe isn't just something out there. It's within you. It is you. Think about that next time you feel small or insignificant. You carry within you the same processes that light up the night sky. The atoms in your body have existed since the dawn of time, recycled through generations of stars, through cosmic clouds, through the formation of our planet, and finally into the unique combination that makes you, you. The quantization of light reveals more than just how stars shine. It shows us that everything in the universe is connected through this fundamental process. From the grandest supernova to the smallest photon, from the birth of stars to the thoughts in your mind, it's all part of the same cosmic story. And you, watching this video right now, are not just an observer of this story, you're an essential part of it. Isn't it remarkable how understanding the quantum nature of light has led us to this profound realization about our own cosmic heritage? We are, each of us, living proof that the universe has found a way to know itself. Through us, the stars have gained consciousness and can contemplate their own existence. This isn't just poetry or metaphor, it's a scientific fact, backed by our understanding of stellar evolution and atomic physics. You are, quite literally, a piece of the universe that has become conscious and is now learning about its own origins. If that's not the most amazing revelation in all of science, I don't know what is. As we reach the end of our cosmic journey today, let's take a moment to gather the starlight we've collected along the way. We've explored some of the most fascinating aspects of our universe, and I hope you're feeling as amazed as I am by these cosmic wonders. We began by discovering how light itself comes in tiny packets called photons, nature's fundamental units of brightness. This quantum nature of light, first unveiled by brilliant minds like Planck and Einstein, completely transformed our understanding of the universe. It's remarkable to think that this discovery, made just over a century ago, unlocked so many secrets about how our cosmos works. We then ventured into the hearts of stars, where nuclear fusion transforms matter into energy with an efficiency that puts our most advanced technology to shame. Every second, stars across the universe are performing this miraculous transformation, converting simple hydrogen into the building blocks of life itself. It's a cosmic alchemy that has been ongoing since the first stars ignited in the early universe. The importance of stars in our cosmic story cannot be overstated. They are more than just beautiful lights in our night sky. They are the factories that create everything we need for life. From the oxygen we breathe, to the iron in our blood, from the gold in our jewelry to the silicon in our computers. All of these elements were crafted in stellar furnaces. When you look up at the night sky tonight, Remember that each star you see is a cosmic power plant, tirelessly converting matter into energy through processes we're only beginning to understand. The light reaching your eyes is evidence of the incredible mechanisms that keep our universe running, a testament to the elegant physics that governs everything from the smallest atom to the largest galaxy. Think about this. The photons hitting your retina right now have traveled across vast distances of space and time to reach you. They've journeyed through the vacuum of space, passed through our atmosphere, and finally completed their cosmic voyage by helping you understand your place in the universe. Each beam of starlight is a thread in the cosmic tapestry that connects all things. These connections, between light and matter, between stars and life, between the cosmic and the everyday, remind us that we're part of something far greater than ourselves. We're not just observers of the cosmic dance, we're active participants in it. As we conclude our exploration today, I want to thank you for joining me on this journey through the quantum nature of light and stellar evolution. Your curiosity and enthusiasm for understanding our cosmic home make creating these videos truly rewarding. If you've enjoyed this cosmic adventure, please consider becoming part of our growing community at Exploring the Universe. Hit that subscribe button and activate the notification bell to ensure you never miss any of our future explorations of the cosmos. Your support helps us continue sharing these fascinating stories about our universe. Drop a like if you've learned something new today and share this video with friends and family who might also be curious about their cosmic heritage. Together, we can spread the wonder and appreciation of our remarkable universe. Remember, every time you look up at the stars, you're not just seeing points of light, you're witnessing the very processes that made our existence possible. The universe is not just a place we live in, it's a story we're all part of.